Hey, welcome to a new lecture. In this lecture, we're gonna see transfer function and frequency response. Before we begin, as usual, we have certain stuffs to remember. First, transfer function is something that's kind of like equation. So, if we are getting a output, the output is the product of the input and also the process. Now we are trying to find the process, or usually input in x and then this is y, so our product would be the ht is equivalent to xt, or hs is equivalent to xs, and so on. Ys is equivalent to xs equal to hs. So in order to find hs, ys per xs. So this is the generic rule that we have. So that is what being translated here. Okay, so in transfer function we have four types. Voltage gain, where voltage out by the in, current gain, current out by the in. Transimpedance, it's just ohms, and admittance, it's Siemens. Now we have the transfer function in the shape of fraction. Now in fraction, the numerator is considered as 0 and the denominator is considered as pole, and then we have this symbol. So usually you can just use s to replace that symbol. Okay, it's the omega and also imaginary unit. Now then we have capacitor. So for capacitor it becomes 1x if it's 2 farad, so it would become 1 per 2s. Okay, then we have our inductor. It's just s, meaning if it's 3 henry it will become 3s. Then we have our resistor. So resistor, if it's 2 ohm, it will just become 2. Now we have this question here. So this question says that determine the function for v. So v over I is r. In this circuit, it means that we need to calculate the total impedance. So transfer impedance, meaning the total impedance. So total impedance is the sum of this. Now this is in the parallel. Now if a resistor is in parallel, what we will do, we will, the 1 zeq is equivalent to as such, but in this case we are not going to do the long one per. So we have the simpler method for 2, which is z1 times by z2 over z1 plus by z2. For 2 thing that's in parallel, we are going to use this. Now first of all, we will translate this in the wording of, in the mathematical notation of S. So 10 ohm is 10, then 6 ohm is 6. So 0.1 F is equivalent to 1 per 0.1 S, which is equivalent to 10 over S. Then we have 2 henry, which is equivalent to 2s. Okay, now we have this. Now we try to settle z1 first. Z1 is this. So 10 ohm, which is 10, plus with 0.1 is now 10 over s. Now z2 is this. So it's equivalent to 6 plus by 2s. Now we know that z total is equivalent to z1 z2 per z1 plus z2. So this is 10 plus 10 over s times by 6 plus 2s divided by 10 plus 10 over s plus by 6 plus 2s. So if we try to do this calculation here, if you simplify it, we will get 60 plus 20s plus 60 by s plus 20 divided by 10 plus 10s plus 6 plus 2s. So if we simplify it more, so we try to simplify as much as possible. So this by s can be removed as multiplying s. So this s is multiplying above, so this s is removed by multiplying below. Do not be confused. So you need to multiply this separately and this separately. Okay, then this one is equivalent to, if you can shrink it, so 2 is the smallest value, so you divide everything by 2, you will get 40s plus 10s square plus 30 and 8s plus 5 plus s square. Now you can group this in the amount of 10, then you write it in the order. So this is the transfer function. Okay, now you could write it as dt, or appropriately you could write it as thus. Okay, now in this is the transfer function. The second is the asking for 0 and pole. So we know that this is 0 and this is pole. So s square plus 4s plus 3 is the zeros amount, and s is for the pole. So do not write as such, because it's just for me to explain to you guys. So our 0, we will get s plus 1 and s plus 3, which is equivalent to s equals to -1 and -3. Now for the pole, I assume you guys know how to use calculator. So if you use the calculator, your pole will be, and this is equivalent to 683 and also 7317. So this is how you solve the transfer function. So the easiest method to use transfer function is s is equal to jw, so just use s, and then you need to know your basic circuit theory. So once you have the equation, just plug in. Remember to change the numeric. Okay, now second is Bode plot. Now before we continue to Bode plot, there is an appendix given, so I need you guys to understand the appendix. So this appendix is, they have given the magnitude and phase. Now they have given the format. Okay, so this, as said, jw is equivalent to s, so it means that s means that 1 per s has power of maybe 2 or something lah. So this is 1 s over z, meaning the amount of 0 that we are going to find. So do not be confused. Then we have k. Okay, now we have been given as thus, we just make it as in the s form, which is easier for us. So it's 5. Okay, so every jw is considered as s now. Now the first step that you need to do is, if you notice here, they have given 2 and also s. Now if it's been s plus 2, we need to make sure that we change it to s over 2 plus 1. Anything that's the numeric, we need to make it as 1. Okay, so in this case, our mathematical equation is, so if we remove these 2, okay, we need to make this as 5 times 2, s over 2 plus 1. Okay, so for the below, it's 10. We need to make sure 10 times by s over 10 plus 1. So the stuff that's outside of the s is not need to be bothered. Now if you simplify this, you will get that 10 s over 2 plus 1 by 10 s over 10 plus 1. So any numeric that's outside of the s, and also, so this s, you need to make sure it's singular, I mean not related to any numeric. So the s is let go, and then the bracket is also ignored. Now the remaining number is 10 by 10, so our k is now 10 by 10, which is equivalent to 1. Okay, so you can write it here, k is 10 by 10, which is equivalent to 1. In any case that k is 100 over 10, then your k should be 10. Okay, now the balance that we have is, this is for the 0 and this is for the pole. Now if you notice, s over 2, meaning that our 0 is now 2, s over 10, meaning that our pole is now 10. It's so easy. Okay, so write it, z is 2 and pole is 10. Also I need you guys to be focused here that this was our original equation. Right? Now, if you notice here, we have finished this, we have finished this, finished this, finished this. So this is left. This is 1 over s. So we need to remember that we also have 1 over s. What is 1 over s? This is it. Okay? Now, we also need this. Okay, need this here so that afterwards, where's the simplest? Okay, we'll just have this here because we need to refer it as soon as possible. Okay, now we have k. So we will be given a graph. Okay, the graph would be a semi-log graph. In that semi-log graph, the shape would be terrible. So it would be something like this. Oh. So what is mean is 0, 10, should be 1, 1, 10. So 1, 2, 3, 4, 5, 6 would be nearer. So this is your semi-log graph. I think you guys would be familiar with it. So we just keep it. And then every time you want to start, you start with 0.1, then 1, then 10, then 100, and so on. Okay. Now first thing first, we check whether we have k. We have k as 1. So 20 log k is equivalent to 20. Okay, our k is 1. So 20 log 10 1 is equivalent to 0. So a straight line in 0 dB. Okay, this is dB, so this is 20 dB and this is negative 20. This is a rough sketch, so beware. Next we check, we don't have normal s, but we have 1 over s. Okay, so we have 1 over s. 1 over s translates to, during the interception of 1, it should be going down, the slope is going down. So this is our 1, so the slope is going down. So maybe from here it's going down. Okay, or maybe best thing is you could do a dotted line. Okay, a dotted line would suit. That's not actually dotted line, but I mean. Then check here, we have over z, meaning that we change the, okay, where is it? Okay, these both are the same. If I write it as such, these are the same, so we know that it's 0. Okay, this is our 0, the above is 0, this is pole, because 0 is 2. Now if you see here in this format, they are telling that from 0 it should rise 20. So our 0 here is 2. So 1 to 10, 2 would be somewhere around here. So from 2 it rises 20. Okay, so it comes here, then it rises 20. Now the second is pole. Now does it look in this format? Yes, if you translate it, it does look in this format where it's 1 s over 10. So our pole is 10. Our pole was 10. Okay, now they're saying from pole it should drop 20. Now our pole was 10 here, so it should drop 20. So this is your Bode plot that has been sketched for each of the magnitude. Now you need to draw something that correlates everything. Okay, in this specific case, we know that it's starting from here. So let me use a different marker. I'll use white. Now we know that it's dropping here, then it's okay. We have two slope now. We'll always take the slope that's in the rightmost. Now we know that it's going up, but technically we won't go up. Why? Because you see, it's going down here, it's going up here, then it's going down back, meaning that the force going up is pulled by the force going down. So it will go as such and it will go down back. Now the issue here is we would be taking a smaller amount called 0.1 here. So what we do is we'll pull this down at the moment of 0.1 at 2, because we know that we are decreasing. Near 2 we are rising, so until 2, then we would go straight until 10 and then we'll fall back. Okay, so this is 0.1 here. Why does 0.1 mean? So we are telling that we are actually going down, but not so down, we are pulled up. So if we are traveling in the 0, it means that we are not going up nor not going down. So by 0.1 we are telling that the force that going up is being pulled by down, so we are at the 0.1. Now this is for the magnitude. What if we are trying to draw for the phase? Now we'll just put it down here. Okay, I'll just show you guys. Now see, we had this line, okay, this dotted line here, okay, then we have this dotted line up here, and then we have the dotted line down here. Now you see the white line that we draw is equal to here. So that's what I'm trying to say. Now the second part is we are going to draw the same, but now we are going to draw for the phasor. Now we'll start with 0.1, 1, 10, 100 as usual, but this time it's going to be 90 and negative 90. If your equation has more, then it will be 180 and so on. Now do we have k? Our k is 1, so eventually it would be 0 degree. Now do we have this? No, but we have this 1 over s. So 1 over s means it should be in negative 90. Okay, so we'll just draw a dotted line, negative 90. Now completed. Do we have this? Yes, we have 0. Now our 0 is 2. Now what they are trying to say is 0 over 10, which means that 0.2. Then 10z, meaning that 20. Now at z over 10, it's gonna rise till 10z, meaning that from 0.2 till 20, it's gonna rise to meet 90 degree. So this is our 90 degree. Now assume this is 20 here, and assume this is 0.2 here. Now this is our 90. So the slope is going to be rising till 90 here. Okay, so we're gonna draw a dotted line as usual, then it's gonna follow straight as thus. Okay, so we have completed it. I'll just make it clear. Okay, they should 20 was here, so 20 was here, so our slope would be something as, okay, it's more seeable now we have completed our z. Now do we have pole? Yes, so pole per 10, which is going to be, our pole was 10, so 10 per 10, it's going to be 1, then it's going to be 100. Okay, now at 1 it's going to drop till 100. Now this is our 1. Okay, starting here till 100, it's going to drop. It's going to be something as thus. Okay, so our line, it's going to be as this. So now we notice that our line, it's starting from 90. Okay, because it's starting from 1, we are going to start before 0.1, so it's going to come like this. Then it's trying to rise till 2. Is it till 2? Sorry, till 1. After that we are seeing that same, this is trying to go up, this is trying to go down. Now if you notice here, we have 90 degree down, we have 90 degree up, then we have a 90 degree down. So eventually we know that it will try to go down. Now the similar thing that happened just now, but here we are using 45 degree. Why? Okay, if you see here, we started at 1. Okay, it rised, but if we didn't have this, we will go to 0. Now here this is going 90 degree up, this is going 90 degree down, so the in between part is 45 degree. So we will try to be in 45 till 20. Now after 20, this is at 90, but this is decaying at 45 degree slope, so we will try to fall back until 100. Then we know that we are straight. Now Okay, we'll try to see here. As said, 0.2 it's going 0.2 it's going up, completed. Then 1 it's going down, completed. Now as said, the line is going up until 1, then it's trying to be straight because something is pulling down, something is pulling up. Then at 10 it started to, sorry, at 20, actually at 20 it started to dropping because here it's 90 degree, but here we are falling at 45 degree rate. Okay, so the method to actually solve this is you need to identify this as over something. So if you have s plus 2, you need to make it as s per 2 plus 1. So when you do this, you will actually get your 0. Now once you have 0, you should draw as such. So this appendix will be given. Okay, for this here, this appendix will be given. So you need to refer it. So the maximum they could ask is these 5 times, but if they are asking more, then you should refer your appendix more. There would be more factors below it. Now if you have 2 zeros, you just need to do as same for 2 zeros. Okay, so this is for our lecture. Thank you.